led the central analytics function for a few years, and then in 2019, we founded an AI R&D group. And that's where three of us kind of carved off, sat in the basement, got off everybody's radar. And you may have noticed the conversation about AI has changed a little bit since 2019. So Gen AI came to the fore, and we had a whole bunch of executives who said, hey, we've got an AI team. This is your problem now. To which I said, oh, thank you for the box of hand grenades. We are kind of leading governance, or we have been leading governance around AI for Zynga for the last couple of years. There's a lot of AI tech coming out constantly, kind of an onslaught, and it's going to be a theme of kind of talking about this stuff. Some of it is quite sketchy. Most of it is at least somewhat sketchy. And it's our job to kind of make sure that like the absolute worst things definitely don't happen, and kind of be the voice of like what should be happening and how we should be kind of thinking about these things in a way that is a little bit more human and industry-centric, as Andrew was kind of mentioning earlier. So I do have to get a few disclaimers out the way first. About 4 months ago, we moved over to Take-Two. People have forgotten that Take-Two bought Zynga, mostly because we were the biggest deal in the games industry for all of 10 days. And then Microsoft bought Activision for significantly more money, and suddenly nobody was talking about us anymore. But Zynga is part of the Take-Two family. And 4 months ago, I did move over to lead AI from the parent company. The way that Take-Two is structured is kind of we have the corporate kind of level, and then we have these labels, subsidiaries. They have their own policies. They have their own positions on stuff. I today am not speaking for 2K Games, and I am not speaking for Rockstar Games. And it's very important that I say that out loud, up front. My first credit was on GTA 4, that was on the previous slide. That is the only reference we're going to make to GTA today. I am not answering questions, I don't know anything. But I am going to be talking a lot in generalities. And one of the reasons that I'm going to be talking in generalities is we don't want to talk about what we're doing internally. So I come here and I say, hey, these are the kinds of things. So I'm not going to be kind of hitting on very strongly on kind of what we're doing internally, what tools we have, and that kind of thing, because that would have triggered a lot of more conversations with lawyers for me. And I have enough conversation with lawyers, thank you. So we've been talking about AI now for the last day and a bit now. I don't think we've ever sort of taken a step and said, what is AI? So I'm going to do that for us right now. I have a really kind of big tent view on AI. Like my kind of position is anytime a computer makes a decision, that's AI. So by that argument, an if statement is technically AI. Questionable, but one of the things to keep in mind is that the computer making a decision is the attribute of intelligence. And we know that, there are times when the intelligence is not that great. And, an if statement, probably not the most sophisticated thing in the world. Maybe would be sophisticated enough to run Go, but that's okay. Because at the end of the day, some humans are not that smart either. We wouldn't say that Peter Griffin hasn't got the attribute of intelligence, but we would say that, like, from a qualitative point of view, maybe he hasn't got a significant value of intelligence. So it's more about, when we think about AI, we're thinking more about like the attribute rather than the quality. And that justifies me talking about a whole bunch of stuff this morning. So, quick pop quiz. When do you think the first article about game AI was written? Okay. Anybody got a different answer than 1980?
65.
65? Anybody else? We got 80, we got 65. 2004. Okay. $1. 1973. Okay. You guys want to know when the first article on game AI was written? We've been talking about this stuff for 250 years at this point. And that is a point that kind of gets drowned out by a bunch of San Francisco tech bros who want to really convince you that this is something that they invented 2 years ago. In 1770, there was this thing called the Mechanical Turk. The Mechanical Turk was an artificial chess player. And this thing lit up the kind of Bridgerton era kind of social scene. It got toured around castles and ballrooms, and everybody was talking about it because you could sit down and you could play chess against a machine. And that was mind-blowing in 1770, and you can imagine that that was pretty mind-blowing in 1770. Now, about 50 years later, there was a fire. And as a result of the fire in the museum or storage room or whatever it was, they ended up figuring out how this thing worked. And the way that it worked is that it was this kind of, you can see the kind of mannequin of the dude and a big table with a chessboard on top. And it turned out that inside of the table, there was a little space where you could put a person and they could pull a bunch of levers. So this did not actually deliver artificial intelligence, but it's kind of like, it's put it in the zeitgeist since 1770. Now, yesterday's keynote covered a whole bunch of history of AI, so I'm not going to repeat too much of it. But there are a couple of things that didn't come up. And kind of thinking about what the modern era of game AI has looked like, I always reference Miss Pac-Man, which is a game from '82. That was the first time, at least, that we've been able to find that there was non-determinism in the non-player characters. So if you look at the original Pac-Man, you can actually solve that to optimality because the ghosts in that game will respond specifically to your input. So if you go left to begin with, the ghosts will always, let's say they go right, they will go right every time. And they will have the same set of responses to the same set of inputs. And that means that for Pac-Man, there is actually optimal ways of playing. And you can go online and you can find these. I don't suggest that you pay that much attention to it because, like, who wants to follow instructions on how to play a game? But that happened. And then Ms. Pac-Man came along and that wasn't true anymore. Those ghosts had personalities and they had biases around how they would respond, but it wasn't deterministic. So for the same set of inputs, you wouldn't necessarily land in the same state. So that's kind of where things started to get a little bit interesting. And then I always like to touch on fear because everybody in the game AI community always likes to touch on fear. It's been 20 years, we probably ought to get over it. But fear is a great example of something from academia making its way into an industry game. So fear uses a system called the Goal-Oriented Action Planner, GOAP. And what that meant was that there was a guy, Jeff Orkin, who's still around today, doing some really interesting stuff at a company called bitpart.ai, so shout out to Jeff. But GOAP allowed you to kind of combine finite state machines with a more kind of planning-oriented kind of way of substituting things in. So it created a world where the NPCs were actually able to kind of be more responsive, be more kind of intentional in how they were acting. So that's a great example of work that was done in academia for Jeff's thesis, being picked up by, I want to say, Monolith, and kind of put into a game and driven forwards from there. When we talk about game AI, for the last 20 years maybe, we've been talking about this kind of stuff. Making the bad guy shoot back, making the soldiers duck behind cover more realistically. It's been a point of contention for me for many years. Obviously, a couple of years ago, the monkey paw curled, and now we're talking about things from a very different lens. But you know, we've been talking about NPC characters, but there's so much more that we can do with AI. So just a couple of examples here. I know No Man's Sky came up yesterday, very procedurally driven kind of space, a whole bunch of worlds and universes kind of being created procedurally. Left 4 Dead is also a really good example of how we can kind of push the boundaries of how things work in games. So Left 4 Dead is another interesting example of technology moving from academia into the industry. They use what's called a hierarchical concurrent state machine and that was developed by the University of Idaho as part of a driving simulation system. And it allowed them to kind of control the pacing and be adaptive to user input and still deliver experiences that needed to happen. So you can imagine in a driving simulator, like if you're trying to teach somebody how to drive, then if you've planned a scenario where they get cut off in traffic and you want them to like respond with hard braking and all the rest, you need to be able to do that independent of how they've been driving previous to that. So that has to kind of just happen at the right time in the right way, no matter where that car has come from, no matter where, what the velocity of the driver's vehicle is. So they developed this system that allowed them to kind of like modulate a scene on the fly effectively. And the folks at Valve said, hey, that looks really cool. Why don't we make zombies about it? And Left 4 Dead actually follows what's called it follows like a narrative pacing arc of horror movies, which is, I don't know much about this stuff, and I'm in a room with a bunch of narrative people, so pardon me while I butcher things for a couple of minutes. So narrative pacing in horror movies kind of, it starts chill, builds up, the intensity builds, and then there's like a peak intensity moment where like all the things are happening and all this stuff is going on. And then like the pace kind of relaxes, the intensity kind of dials down, and you know, your group of teenagers who have been chased through the woods get a couple of minutes reprieve, and then the whole kind of cycle starts over again. Now, how do you bring that into games when, you know, the players are going to do different things and all the rest? Well, you use one of these, or a bunch of these hierarchical concurrent state machines, and you're able to kind of hit that same pacing where even the weather effects, the ammo and stuff that you're picking up in the world, and how many zombies are spawning and how they're interacting with you, are all under control of an AI director. And the director is managing that experience in real time. So these are just a couple of things about what we've been able to do for quite a while. Before folks like Sam Altman turned up, we were doing cool stuff. So that kind of brings me to this taxonomy of game AI, and this is actually something that I probably can say we've kind of got internally at this point. It's kind of trying to break out AI into the components that are it. Because at the moment, everybody wants to talk about this one. But when you're making games, all four of them, and arguably, you know, the three on the left are the more impactful ones, and then the one on the right, questionable. So, you know, making sure that when we talk about game AI, we're talking about all of it. You know, we should be using all the tools available to us, not just glomming onto the hot new thing that we read about on TechCrunch, VentureBeat, name a thing. But this is called the Transformer Conference, so we need to talk about some of this generative AI stuff, so let's do it. We've talked yesterday about diffusion models and generative art and chat assistants and LLMs. So I'm not going to go kind of crazy deep on this stuff. You kind of have seen a bit about how it works already. This is kind of like, it didn't come out of nowhere. This is one thing to kind of think about on this slide is like, it felt like everything kind of exploded in kind of maybe 22, 23, but this is building on work that has been coming for a long time. Transformers were, I think, that architecture was maybe 2019, the paper was published. And, you know, adversarial networks have been kicking around for a while. Like the things that are the kind of theoretical algorithmic building blocks have just been kicking around for a little while. And honestly, the big breakthrough was taking those kinds of systems and putting them into a chat interface. That's what OpenAI did that was transformative, was not anything about necessarily the math of the thing, but it was about the UX. However, we've got to acknowledge a whole bunch of lawsuits about this stuff. They have just taken everything from the internet and shoved it into one system, and that probably shouldn't be legal. And we'll find out over the next year or two if it is. So there's a whole bunch of lawsuits, and many of them got referenced yesterday. Consistency is still a problem. Control is still a problem. These are things that are not really solved, and they're baked into the nature of how the technology and the algorithms actually work, to a point where there's a lot of effort being put into solving them in a way that is like, well, can you overcome the inherent infeasibility of the algorithm? Or should we maybe stop just pouring a whole bunch of compute at this and hoping that it all gets solved? So you've probably, if you're following the AI space, you've probably heard the word agents being thrown around over the last 3 to 6 months. Agentic systems, multi-agent systems. So about 20 years ago, I took a course on multi-agent systems. This diagram is from a paper, I think this one was from '91. And the point I really want to drive home is most of this stuff existed already. All the buzzwords, all the stuff, it's just a bunch of people who are reinventing the wheel yet again. You remember when they decided that they were going to reinvent a bus? And they were going to do like, oh yeah, we're going to do this thing where like we're going to get big Ubers and we're going to drive them down the street and you can press a button on your app and get on the, yeah, that's a bus. You know, we're going to do this thing where we're going to build a tunnel and we're going to put like a car in it and it can go along and you can get from point A to point B. Yeah, that's a fucking subway. Like, what are we doing here? So, we need, you know, this has come up actually a few times yesterday and I'm really happy about that. Because when I say that these lawsuits are outstanding, when I say that they've stolen work from people, like, it's important to remember that. I don't know what the answer is, because the way these systems work, they just grab everything that they can, and then by the time it gets to the finished product, the math has obfuscated what bits of what are being used. So attribution is going to be hard in these current architectures. That's not a reason not to have the conversation. You know, at some point, I've got to be able to look artists at Zynga at Take-Two in the eye and say, hey, you're not why we're putting you out of a job, or I'm not why we're putting you out of a job. And that's an important thing, right? Like, you can draw a line from where we are with AI technology today to the end of capital A art. And that should be scary for everybody at a societal level. You know, the Netflixification of kind of content is maybe not the best thing in the world, but doing that at scale across an entire set of industries could have some really gross implications for everything. You know, we seem to be very much speedrunning idiocracy at this point. So, you know, that's great. All right. So the session's called Practical Applications. But honestly, having a rant about some impractical applications is a lot more fun. So that's where we're gonna start. All right. Haven't seen one of these for a little while. But a lot of people kind of think that we're going to take prompt to game. I can write a paragraph, press a button, and get a game. DeepMind's Genie system on the left there has a bunch of prototypes that they've kind of put together. These are actually grabbed from their website. And this is part of the kind of shell game that's played with games. So games are kind of 3 different things. We've got games as art, games as technical product, and then we've got kind of games as toys. And those 3 things are quite distinct. This thing on the left is a toy. Like, it's a little platformer that looks good, but it's not a game product, and it's not really a piece of art. It's a toy. So we're using the word game in different ways and kind of in the kind of framing of the thing, obfuscating the fact that, you know, if they can generate this, that's great. They can't generate actual commercial products. That's not a thing that is going to happen really anytime soon. And this system, Nilo on the right, is a really interesting thing. It's aimed at kids, and it's effectively trying to be Gen AI Roblox. And part of my question is like, well, why is Roblox not going to be Gen AI Roblox? But what they're doing here is, instead of kind of doing the kind of bait and switch on this being kind of a toy game rather than a game, is that these guys are actually getting a lot of success by really limiting the scope of what that game environment is and can do, and kind of constraining to a whole bunch of, or a small bunch of verbs, gives you more control over the space. So that's kind of how these guys are managing to get prompt to very specific implementations of things. So it's not that it kind of can't be done, it's that in order to kind of make it happen, you really have to be very clever about how you define a game. I think I'm going to piss some people off with the next slide. LLMs for NPC dialogue. And NVIDIA's Covert Protocol demo, which came up yesterday as well. If I have to deal with one more group of people who think that the best thing in the world for games is to take an NPC and anchor an LLM to it, I'm going to lose my mind. This demo, it's fine. Getting hands-on with it, you start to kind of see that some of the stuff that they put online is the good parts of it. Unsurprisingly, that's the game. LLMs anchored to NPCs sounds great, right? It sounds like what should happen. Except, so Sid Meier of Firaxis fame, so obviously Microprose, Firaxis, part of the 2K family, so I am quoting somebody from my own company. But he defines a game as a series of interesting choices. Connecting an NPC to an LLM gives you an awful lot more choices. Doesn't make them interesting. And one of the key things here is that when we're talking about in-game, we're talking about curated experiences. We're talking about systems that are trying to say something. And when you just connect them up to like an all-seeing kind of like, hey, we can just say a bunch of stuff, you lose a lot of the intentionality. You lose a lot of the drive and the point of the thing. And if you look at this Covert Protocol demo, it's very tightly constrained. Taking a step back and thinking about a interview that John Riccitiello did when he was, during his stint as Unity CEO, sorry. One of the things that he said was like, wouldn't it be cool if you could play, when you're playing Madden, you could wander around the stadium and like you could like sit in the stands and watch what's happening on the field and talk to the person next to you and like you could get the grandmother's lasagna recipe. No, that wouldn't be cool. Like, I don't start Madden to learn about lasagna. I start Madden, well, I don't start Madden, but like you play Madden for the NFL and for the running the game side of it, not the let's go talk to random people side of it. And this is where like the intentionality of the thing really matters. What are these characters supposed to say? What is their role in the story? Because if you make them fully embodied, you could go out into the real world and talk to fully embodied people out there. It's not super interesting. Vibe coding. Vibe coding is one of the best things in the world ever for about an hour. So for those of you, this came up yesterday as well, but for those of you who don't know, vibe coding is when you sit with one of these assistants and you say, hey, I want to do X, Y, Z, and it goes off, writes a bunch of code for you, and you run the code, game over. And that's great. So for a simple project, I want a script that does one thing, great. So one of the things that I do a lot is I DM D&D games, and I'm running one right now that's got, so for the nerds in the room, it's a West Marches game, so there's 26 players in this game, there's a whole bunch of scheduling to kind of figure out, right, I'm gonna vibe code a Discord bot. So got up and running, got a thing, got it hooked into Discord, got some basic commands going, right, now I want to anchor into the Calendly API for scheduling. Well, first off, it just made up how that API works. But the more the complexity that got introduced with this bot, the more this thing started just tangling itself up in knots. And then you say, hey, actually, this bit and this bit need to be abstracted out, and I need to refactor this thing. Everything breaks. Because like, once you achieve a certain level of complexity, vibe coding is not going to get it done. But you also don't know how your code base works, and it probably doesn't work the way that it looks like it ought to work because it's not been written by a person, it's been written by an idiotic machine that just went, this works. And that's a problem. Because the more that we rely on the vibe coding side of things, the more that we're going to get tech stacks that we don't understand, that we can't maintain, that are just a disaster. So we're kind of exponentially accruing tech debt when we vibe code. And we were already kind of accruing tech debt a little bit faster than we ought to be. So this is kind of problematic, probably not today, but 18 months from now, wow, that's going to suck for everybody. All right. Regression to the mean is a really interesting thought with Gen AI. Gen AI has been trained on everything. It's been trained on the entirety of the internet. It's been trained on a whole bunch of images. It's not been trained on the good stuff. It's been trained on the good stuff and the bad stuff and the mediocre stuff. And that's going to look like a Gaussian curve. And that means most of it's going to be mediocre at best. And this kind of ties back into vibe coding and code assistance. You know, one of the things that I've definitely found is that if you're a bad coder, if you don't know how to code, if it's not necessarily, you're not an engineer, you're maybe a designer, great. A coding assistant will make you a mediocre coder. Fantastic, we love that. If you're a good coder, coding assistant will make you a mediocre coder. And this is kind of like the ongoing problem. So in this image here, this is a sailboat. And it's an image out of, I think this one's out of Midjourney from maybe 6 months ago. So argument that maybe things have got better, but they haven't got this much better. This looks boaty as fuck. This looks amazingly like, hey, this is a sailing ship. I know what's going on. We're on the ocean. There's a whole bunch of waves. Great. Now, everything that comes out of an AI system, to me, looks pretty good. I've got the aesthetic sense of a brick. But the thing that I do have, because like my first job was working at a boatyard. I've been doing a lot with boats over the years. I raced sailboats back in Scotland. So I don't know a lot about art, but I know a lot about boats. This is wrong. That being tied off there, that's weird. That shouldn't be done. That is just hanging out. That's not connected to anything. A whole bunch of these ropes do not exist for reasons except to give the vibe of boats. And like, if you don't know what you're looking at, you can look at that and go like, yeah, that's boats. But when you do know what you're looking at, you can look at it and go, wait, hang on, what? Somewhere I've got a different example where the wind is going 180 degrees at different parts of the boat. Like some of it is going this way, some of it's coming this way. Because that's not conceptually something that's being represented in these systems. They are just kicking out like, hey, this looks like boats. And if you don't know any better, great. People in your audience, people who are your players, will know better, and this is why a lot of people are dragging, it's not the only reason, but it's one of the reasons that people are dragging these Gen AI systems. It's like, they're not producing stuff that is actually coherent. They are producing something that kind of highlights a vibe. All right, that's the ranting done. And we're a bit short on time, so let's just keep going through some practical applications. So this is the kind of stuff that I think you should be thinking about when you come to actually implement these things. First question I've got for people is like, do you want to deploy this stuff at runtime or do you want to deploy it at dev time? That's a key consideration. There are certainly areas where deploying an AI system at runtime might make sense, but in general, like having it help with development is probably a safer bet. And this actually comes back to the LLM example. So I talked about how the choices wouldn't be that interesting. Particularly in the free-to-play space, it also creates a really big problem for us because it's not a monetized, or generally, it's not going to be a monetized thing. So your players are going to be able to interact with these NPCs, and that inference has to happen somewhere, and it's going to happen in your tech stack, whether you might, at low scale, maybe you're running that kind of on a desktop machine, but at big scale, you'll be running that in the cloud. So what happens the day that your game, whether it's on itch or Steam or wherever, makes it to the front page of Reddit, or gets pirated, and this actually happened to somebody. Game gets pirated, and suddenly they have a whole bunch of non-paying users in there. But when they talk to those NPCs and they ask all those questions, they're racking up bills. And that's a problem, because now you've got folks who are not paying, but are costing you. And the margins in games are not so big that you can really afford to do that, particularly because like, if you want people to monetize somewhere else in the game and you've given them a reason to just hang out and chat with a buddy, you're not moving them to where you need them to be. You're just having them sit and accrue a cloud bill for you. That's concerning. So this is one of the reasons that I think that dev time is a better kind of place to deploy this stuff. The other thing is control. If you deploy it at runtime, you don't get any kind of directorial or authorial control over what it's doing. You just have to trust that it's going to do something that is good for users. If you're at dev time, you get to curate the hell out of it, and you can throw the stuff away that isn't useful. So that's kind of practical piece of advice number one. Stick this stuff at runtime. Stick this stuff at dev time, and maybe be a little bit more concerned about kind of thinking it through when you're putting these things inside of the game themselves. Tools or tech. We talk a lot about models. We talk a lot about all the different things that are happening out in the world. Yesterday, Adobe dropped Firefly v4. It's got a whole bunch of improvements. It's great, allegedly. I don't know. Firefly version 5 is going to be a few months around the corner. ChatGPT is going to have some new image things. Diffusion models, Flux, all these things are leapfrogging each other constantly. Stop caring about the models. The models kind of don't matter. They're going to get incrementally better over time. What matters is the tools and the UX and the workflow. At the end of the day, if you're building this stuff to empower artists, which is what we're trying to do, it kind of doesn't matter which model you're using. I mean, for different applications, different things are going to be better suited. But if you're in a world where you can kind of build out over a bunch of them, it doesn't matter which one's on top. But then you can have a consistency of UX, and you can actually build tools for art teams or for dev teams, you know, for anybody who's working in the space that is consistent, that does what they need it to do. Midjourney caught everybody's attention as a Discord bot, basically. You could go onto Discord and you could type in some stuff and you could get an image. Great. That's not a great workflow if you're a dev studio. Like, that's not great to have to then export out of Discord, do the thing. Took a while for Midjourney to put a web interface in. But stuff like this is pretty close to some of the art tools that the teams are using already today. So they're familiar with it. They understand layers. They understand how to export stuff. Show them the new stuff. Get them working with it. But at the end of the day, if you treat it as a tool and you don't obsess about the models, then the tool will be the tool a week from now, 6 months from now. And it doesn't matter who's doing what in the space. You know, you are basically future-proofing yourself. An area that we kind of focus on asset generation, right? We focus on kind of how we can use it for concept art. How can we maybe use an LLM for designing narrative stuff? Those are low-hanging fruit of varying quality. But some of the stuff that we don't talk about is how we can use these things elsewhere in games. A lot of games have chat in them. A lot of games that have chat in them have massive moderation problems. I mean, this is not new information about how these games work. Systems like this are effectively natural language parsing. And that means that you've got a really good ability to actually, instead of doing kind of player-facing or asset generation or anything like that, just on the back end, be running systems against your chat feed and be like, okay, well, now we're in a much better, more robust position to find stuff that's bad inside of our game and proactively get involved. That's a big opportunity. That's not something that really gets talked about in, I mean, it gets talked about in places, but when we're talking about it in a setting like this, it's so easy to focus on like, hey, this is how we're going to get 3D models and 2D images and audio. But stuff like this actually is the stuff that we can't do today that isn't really as ethically concerning, because like we can't do this. We're not putting people out of a job because we can't do it. So by putting systems like this in, we get a better experience, and there's not as much of a human cost to it. And then one thing to always keep in mind is that if you're running a game studio, you're a business. And everything that applies to any kind of enterprise applies to you. Whether that is, an email rewriting assistant, whether it's something that's going to help you parse contracts. I think there's a system called Harvey that's good at that side of things, whether it's helping you with decks, helping you with branding. But these, again, these are the things that are boring as hell, but as a business are becoming kind of table stakes. And that's where there's also kind of not as much emphasis. But grab these things, play with them, be aware that from a 3D object, 2D image kind of point of view, there are legitimate concerns, and there's concerns on the training data source. But at the same time, the obvious places that you can see to just grab onto and go from a game dev point of view are not the only ones. And when we think about practical applications of AI in games, we could do so much previously. We could do a lot of stuff with AI that a lot of studios thought was witchcraft and did not want to go near. And one of the things that's cool about this moment is that they all want AI now. Everybody wants to do stuff with AI. Now, in their heads, they mean LLMs, they mean diffusion models, but it's all AI. Level generation is something that we've opened the door to because people are more receptive to the conversation. This is an interesting demo from early 2000s, I believe. This is Silent Hill Shattered Memories. And what's really interesting about Silent Hill Shattered Memories is that they had a very rich personalization system. And that was built around an ML system and a player persona system. It's Silent Hill, so it's kind of horror themed, and it opened in a therapist's office. And the therapist is asking questions, and the player character is answering those questions. And the conceit of the thing is that you are kind of getting a psychiatric evaluation. What's actually happening is that the player is getting a psychiatric evaluation. And that created a world where they actually developed a whole bunch of content for this game, and they actually switched between it. So this character is this character, and it's this character. And depending on how you kind of tested on that initial psychiatric evaluation, you get a slightly modified experience. Some billboards get swapped out, some characters get swapped out. There's a slightly different tone shift. Now, the way that they did that was to make 3 sets of everything. It's not the most efficient way of doing it. But at the time, this was groundbreaking. And this was stuff that really kind of showed what personalization can do, because we were playing different games. And now, we see that in branching narratives. Your playthrough of Baldur's Gate is going to be very different from my playthrough of Baldur's Gate. But that's based on choices, not kind of trying to assess what we think people want. And that's the important thing. My thing for the last 15 years has been that AI in games should follow D&D. The Dungeon Master manages that game experience. They start out by figuring out who's going to sit at the table. The social composition, the psychological profiling of well, I'm not going to put that person and that person together because that will go badly. Alternatively, maybe you do that. But a Dungeon Master's controlling the matchmaking, they're controlling the narrative pacing, they're controlling the combat encounters, they're controlling the economy. They're controlling all of these things in a human-led way. And if we think about what AI could be for games, ultimately it's about taking the Dungeon Master human away and replacing it with an AI, at least for me. And that's probably because I grew up as an only child in a bit of a rural situation where I didn't have people to play these games with. So being able to play them with fewer people, that's my jam. But this is stuff that we can do. We've been able to do it long before these new systems showed up, but we didn't compose all the pieces together. And this is kind of leading up to all the stuff that we're talking about. Cool. It's low-hanging fruit. The real question for me, the thing that I want to chase is okay, what new game experiences can we give people as a result of these technologies? And I haven't got an answer to it. If I had an answer to it, I probably wouldn't be able to tell you. But this is the star in the sky. It's more important than we can make images quicker. We can, make our 3D objects just integrated into our pipeline. It's more important than all of that stuff because this is again stuff that we couldn't do before. We can't do it today either, but we're going to figure it out. So part of what I wanted to give you is like a rubric of practicality. Like when we think about practical applications, how should you be thinking about it? Cost is important. And a thing to keep in mind is a lot of these systems are being sold under cost. Classic private equity and VC model where they did this with Uber. They funded the hell out of Uber. Uber came in super cheap, ran the taxis kind of into the background, and then Uber jacked the prices up because they got you locked in. That's going to happen with a bunch of these things. They are going to become more expensive. How do you control for that? How do you control for users who can touch things, maybe racking up bills like we were talking about earlier? Speed is a big factor. Like, how do you make sure that you can make things fast? I mean, this is the promise of AI, right? You can kind of make your pipelines run a whole lot faster. But do you need to? Maybe, maybe not. So keeping in mind that speed is important, scale is also important. If I want to create like a Silent Hill Shattered Memories, making 3 sets of content is 3 times the work. But there's a reason for doing it. So now we're sort of like, okay, well, let's do it this way. It's faster. Maybe it's a third of the time, which means that we can do 3 in the same amount of time. Control's important. Maintaining that authorial control is critical. Like, your game is supposed to be a piece of art that is making a point or saying something. Don't let ChatGPT say something for you, because that's like not remotely interesting. And like I was saying earlier, future-proofing. What's going to happen next is a whole bunch more models are going to get dropped, and everybody's going to hype out about them, and it's all going to be fine. They're going to be incremental improvements. So how do you make sure that you're agnostic to those improvements? If you're really tightly coupled with OpenAI, you can't benefit from DeepSeek, which came out a couple of months ago. It came up yesterday. DeepSeek came out of left field, and everybody was trying to scramble to react to it. A lot of where my attention is like a layer up, which meant that we could just kind of get DeepSeek deployed, and it was in the tools that we already had. So kind of keeping in mind that that is what's happening. We're in this kind of weird arms race between tech companies, and we're kind of caught in the middle. So making sure that you understand that that advancement is still going to continue. So how do you leverage it? Here's the big thing, though. This is the important one. So the original IBM is a computer can never be held accountable. Therefore, a computer must never make a management decision. I prefer this framing. But this is important. We can't abdicate our decision-making to these systems because they are not decision-making systems. They are predictive systems of spit out the next word. They don't know things. They don't understand facts. That's not a concept that's kind of part of the math. So one of the kind of core things that I often push back on is like, are we actually automating a business decision here? Because that's a terrible idea. Let's not do that. Let's make sure that it is assistive to a human, maybe, but the human can say, whoa, don't think that's right. Let's not do that. I've certainly seen proposals for like, well, we asked ChatGPT what game we should make. That's really bad. Don't do that. This is something that we're seeing across industries, right? AI is being introduced into insurance claim approvals and more often denials. That seems not great. Actual humans need to make decisions. These things can inform them, but if they're making the decisions, wow, things are going to end up real bad. Idiocracy might be the best case if we go down that route. The Matrix is maybe where we land up. So I did want to kind of leave you with some final thoughts, and I know I'm a little bit over, but I'll just jam through this as quick as I can. This is Pixar. And the moment that we're in right now feels a lot to me like where Pixar was maybe 20, 30 years ago. So Pixar started as a spin-out from the University of Utah. There's a bit more history and backstory to it. Creativity Inc. is a really good book if you're interested in this stuff. But the punchline is that the Pixar folks, Ed Catmull and his co-founders, wanted to understand what movie making with digital tools would look like. And at the time, the state of the art was Disney animation. Like, Disney has always been the pinnacle of this stuff. And what they would do is they had a whole bunch of artists who sat and drew frame by frame. Now, there's a world where you say, okay, we're going to be digital. And you can imagine executives saying it in exactly that way. And what you do is you take Photoshop and you give them like a tablet and you say, cool, you're doing this digitally now and you're still drawing frame by frame, but you're doing it in Photoshop. Congratulations, digital. That's not what good ended up looking like. Good ended up looking like stuff like Maya, stuff like Autodesk, actually building 3D scenes and then rendering it out as 2D. What we're seeing today is today's workflows getting AI crammed into them, mostly to satisfy investors. You know, half of the features that are being rammed down our throats are not actually that useful. But they're trying to fit it into an existing workflow. What is the new workflow? What does it look like to make games in an AI kind of native way? That's a big outstanding question. It probably does not look like Photoshop, Perforce, all the things. You know, it doesn't look like the tool chain we have today. We don't know what it's going to look like, though. The magic trick is done. Everybody wants to think that AI is this thing on the left. It's just going to go up and up and up and up and up. You know, the next ChatGPT, the next Claude is going to be exponentially better than the previous one. It's not. Unless we fundamentally change the architecture, and that's some of what's kind of starting to happen in some of these papers, we're here. And we're actually here because everybody sort of started paying attention maybe here, but AI started here. AI started, you know, best part of 60 years ago, 70 years ago. You know, this is not a new thing. This is not something that's taken off and going up through the roof. It's something where we've had a step function, we've had a transition into these new systems, but now they're starting to plateau. You know, they've been talking about ChatGPT 5 for a long time and how amazing it's going to be. It ain't here yet, and they've been talking about it like it's a real thing for a while. Where is it? And the answer probably is that they're hyping up their company to juice their valuation. And this next thing is probably a little bit better, sure. But is it like transformationally better? Probably not. The transformation has happened. Until we have some new massive breakthrough, we're not going to see that step function again. I want all these tech bros off my lawn. We're still here. And we've been here before. In the AI space, we have this notion of AI winters and AI summers, because this cycle happens to us constantly. You know, everybody hypes the hell out of machine learning or neural nets or expert systems from maybe 20, 30 years ago. It's the new thing. It's going to transform everything. It's going to be the thing. And then it doesn't. And we end up here. And nobody's funding this stuff. Nobody wants to know because it all got overhyped and overblown and it could never deliver on those promises. But here is where the interesting stuff happens. When you cut through that hype, when you get back to like, this is what these systems do well, and this is what these systems will never do well, so let's stop talking about them, and I can actually focus on the real opportunity. But wow, you need everybody here to calm down. So that kind of transitions into just a kind of quick shout out to my team. We're 25 people. We've got a range of AI folks, engineers. We've got some product managers and producers now. But we're kind of pushing on the boundaries of some of this stuff, and we're also pushing against the kind of inevitable tide of some of the other stuff. I'm not going to go through our projects. There is some stuff published around Spellforest because we actually got some software patents on that, which meant we could talk about it because it's fully been disclosed. We are going to be growing through the year, so we are going to be opening some roles later on, probably next month. And we've hired our interns for this summer, but we do have postgrad internships generally. They'll be opening up in the fall. So that's kind of the this is the justification for why I'm here. I'm here on a recruitment trip. So let me leave you with these. This is kind of as best of an encapsulation as I can give you. Everybody's paying attention to the trees. Look at the forest. Look at the entire thing. Don't focus on what's happening with just the one tree, because everything across the board is impactful. Now, I keep kind of referencing the ethics stuff and the copyright lawsuits and all the rest. Genie's out the bottle. Like, it's not going back in. There could be a ruling tomorrow from the Supreme Court that all these things are illegal, and they are still out there, they are still available, and maybe you can't run them on AWS because AWS will get sued, but you can run them somewhere and you can grab them from somewhere. This genie's not going back in the bottle, as much as you might want it to, as much as we all might want it to some extent. The final thing is this. These things are dangerous. And one of the big concerns that I have is the lack of any kind of rigor or common sense being applied by some of these tech companies. You know, look, you can deep fake a video. Cool. What are the social implications of that? Because that's scary as hell. I think of this stuff as plutonium. Now, there's cool stuff you can do with plutonium. There's also some really dodgy stuff, and in either case, you're probably going to end up really screwed if you're the one doing it with plutonium. It's not to say that it's inherently bad. It's not to say that it's inherently good. You know, it keeps coming up that, you know, AI is just a tool. To some extent, that's true. But tools can be used for bad and for good. And it's important to be mindful that just because it's a tool doesn't abdicate our responsibility to use those tools effectively and ethically. And I think that might be it. Yeah, okay. So if you're interested in those roles that are coming up, follow me on Blue Sky or on LinkedIn. I'm deliberately not giving you my email address because, as the conference organizers are aware, not super on top of my email. But yeah, I guess I don't know how we are for time, but find me through the day. If
questions, Doug, do you want to push back a couple more minutes for? Sure. All right. Well, thank you, Luke. If you have questions, we'll shout them out to Luke. He'll repeat them into the mic for the live stream. So.
I just have a question about do you still have the Discord page paper?
the what? Sorry.
The Discord page.
I'll bring that around later.
Oh, okay.
Yeah, I don't know if everyone can hear me. I don't have
I'll repeat.
Okay. Yeah, I just wanted to ask if you wanted to give any comment about matchmaking and what might be possible in this new era with, diminishing toxicity, promoting coalescing teams, or finding better matches.
Yeah, so the question is, like, how does matchmaking change under Gen AI? And I think the answer is it kind of doesn't. It's one of those things where, like, matchmaking with Big Tent AI, super good. But the techniques that are actually going to work there are more on the machine learning side of things than they are, like, the neural net spitting out stuff. What might be interesting is how we think about players and how we think about something that's describing players in order to feed into a matchmaking system. So I could imagine that there might be something there in terms of, like, hey, summarize this player's behavior so that I can then feed it into a matchmaking system. But the matchmaking is always going to be math, I think.
Yeah.
I just want to ask, my general problem with AI is that, like, when you make your thing, the AI doesn't know why you're making the thing. So, like, when it comes to generative AI, do you think there's going to be a point anytime soon where it's just like, okay, I'm making a game about, I'm making a game that's a commentary on, I don't know, religious tensions and stuff like that. If you, do you ever think there's going to be a point where the AI is like, okay, I understand your perspective and I can construct a story, like I can construct a space opera that's essentially telling you the same thing about that, and it being like something that feels human-like versus it still being just like LLM garbage.
So for the stream, the question is, and I'm going to summarize, yell at me if I get it wrong. So the question is kind of like the intentionality. The intentionality of kind of inferring context from prompts in order to kind of produce more intentional output, I guess. I think there are ways that could be a thing. I think that in general, it requires a kind of additional layer of complexity that I think is going to be hard to actually achieve. But you could imagine that rather than a single holistic system, you could almost imagine like buzzword alert agents, but like one agent that's about intention feeding forwards into something that's about background that's kind of, so you could squint and kind of see a hypothetical world where you can compose a system like that. Is it going to be effective? Question mark.
Okay, I'll ask the last one. So in the chat, loved it, by the way. Someone talking about intentionality specifically said that what you said, please plate that in gold, crochet it on a pillow, and I will sleep on it every night.
Okay. Oh, sure. Okay.
But one area we didn't really touch on was AI for QA.
Yes.
All of us who make multiplayer games, we've used our own AI to test the multiplayer forever. But are these tools, is there a role for any of these new tools really to come into the QA process?
It's a great question. Model AI got referenced yesterday. Really big fans of Model. They have a really good team over there, and they are pretty stacked. A lot of the interesting work in QA is more focused on reinforcement learning. Now, what the Gen AI element can get you, and I believe Model has this feature and showed it to us at GDC, but all my GDC demos kind of blended together, is more kind of a more traditional kind of bot agent going through whether it's screens in a more kind of UI-centric mobile game or running around a 3D environment. But the ability to use the Gen AI to summarize what happened, to summarize that playback, to look at segments of video even and describe what happened. So instead of having to explicitly catch, oh, there's something with the colliders here and the player character fell through the geometry. Like, you would need to have a whole bunch of like triggers that are kind of catching when that happens and alerting and all the rest. You can say, hey, something happened, you know, a reinforcement learning agent can get to like, something weird happened here. If you're capturing the playback, you can then feed that into like a descriptive system that will be able to kind of analyze the video and be like, oh, yeah, this is what happened. And then create a JIRA ticket for you or create a bug report in a bug reporting system or, you know, however you want to approach it. But like the Gen AI-ness of that is kind of taking the existing systems that we have and connecting them up to output in a more kind of reasonable way. And this is kind of where this stuff is, right? LLMs are word predictors. That's it. Like they predict the next word that is most likely or kind of within some bounds and poking around what's most likely. That means that if what you need to do involves outputting a bunch of words, ace, you're off to the races. And if what you need to do involves any kind of insight, be careful. So in this case, the use of the Gen AI is actually outputting a bunch of words. Great, love that, great use of the system. If you were to try and connect up, you know, a player to a Gen AI and effectively do a Twitch plays Pokemon with your game, only with an LLM as the chat, that probably would go pretty poorly. Feel free to try it. Get back to me.
All right, thank you very much.
Thanks, y'all.
Great stuff. Time for workshop.